Hello everyone, welcome back to Edexcel Science channel. And now we are at question 17 from 2026 June IAL Physics Unit 2 paper on Edexcel. Graphene polymer is a flexible conducting material used in sensors that can be worn on the body. A strip of graphene polymer has a length of 15, width of 2.5 centimeters, and thickness of 1.1 times 10 to the power minus 7 meters. The strip is connected to a cell with negligible internal resistance. There is a current I in the strip as shown. Determine the resistivity of this graphene polymer. So let us first of all write down all the information that we know in this diagram, okay, so that it's easier for us. So the length of this polymer is 15 centimeters. The width of this polymer is 2.5 centimeters. And this thickness, guys, okay, this thickness is 1.1 times 10 to the power minus 7 meters. Now we know that the formula for resistivity is RA divided by L, right? So we now have to find out what information we do know and what we have to find out. So do we know the resistance? Have they given us the resistance over here? No, but they have given us the voltage and the current. So we can find out the resistance. Have they given us the cross-sectional area? No. However, we do know the thickness and the width of the polymer. So we can also find out the cross-sectional area. So let's find out the required values. So we know that V is equals to IR. So from here, resistance is going to be V over I. So the EMF, the electromotive force of the battery is 1.5 and the current is 0.12 amperes, which is going to give you about 12.5 ohms. Okay, so we are done finding out resistance. What about the cross-sectional area? Cross-sectional area is just a product of the width, which is this one. No, sorry, the width and the thickness. Okay, do not take the length, guys. That will give you a wrong value. So width times thickness. So width is 2.5 centimeters, but we have to multiply a 10 to the power minus 2 to convert it to meters. And the thickness is 1.1 times 10 to the power minus 7 meters. That is going to give you 2.75 times 10 to the power minus 9 meter square. So now we have all the required information that we require to find out the resistivity. So resistivity is Ra divided by L. You can find out this information in your formula booklet. It's not necessary that you remember it. This is a really nice thing about physics, that you don't have to memorize most of the formulas. So resistance is 12.5 ohms. Area is 2.75 times 10 to the power minus 9. And the length is 15 centimeters, right? But we have to multiply 10 to the power minus 2 to convert it to meters. And that is going to give you 2.29 times 10 to the power minus 7 ohm meters. Okay, that is it for question number A. Moving on to question number B. A stripe of graphene polymer is used in a sensor worn on the body. When the person moves, the strip of graphene polymer is stretched along its length. A student suggests that doubling the length of the strip of graphene polymer would double the resistance. So the claim is that if the length increases by twice, the resistance will also increase by 2 times. Now, is this correct? Okay, this is basically our, not our, the question's claim. Okay, deduce whether the student is correct. Now, guys, there is a slight bit of confusion about this question. Okay, that you might face in the exam, which is that they are not. So let's say that I draw this polymer over here. Okay, so let's say that this is the polymer. Okay, these two are basically the same thing. Okay, now what they're telling you is that they are not actually adding another polymer. Let me copy paste this. They are not actually adding another polymer to increase the length by twice. What they are telling you is that there is hints in the question. You see, in the first it says that it's a flexible material, and now it is saying that the stripe of graphene polymer is stretched along its length. So they are not actually adding another polymer to increase the length by 2 times. What they're doing is that they are going to stretch it by applying tension on this polymer. Okay, this very polymer. So if you apply tension on both sides, right, what you might see is something like this. Okay, what you might see is something like this. Okay, this polymer is now stretching. Okay, so this is something that is very important in this question. If you do not understand this part, then you won't be able to answer the question at all. Okay, some students might think that, okay, so they're basically now adding another polymer, so the length is now twice. No, they are literally stretching the polymer itself so that it increases in length by 2 times. So now let's answer this question. Okay, so we can agree that if they are stretching the same polymer, the volume is constant, right? The volume has not changed. So the first point is that volume remains unchanged. Now, the second point is that if you increase the length twice by stretching the same polymer, the cross-sectional area is going to be half. Let me put it in different words so that you understand it better. If your polymer is twice in length, okay, if it is twice in length, okay, then it will be half in thickness, right? If you increase the same thing by pulling it from two directions and increase the length twice, it will become half in thickness, right? On top of that, if your thickness is half, then your cross-sectional area is also half. Okay, I think an easy way to look at this is like this. Okay, let's say you are going to make a pizza. Okay, let's say that this is a pizza and you use, let's say, 100 grams of flour to make that pizza and you eat it by yourself. But let's say that one day you have a friend at home and you only have 100 grams of flour. So what you will have to do is you will have to increase the size of that pizza, right? So if the same 100 grams now have to serve two people, then wouldn't the pizza be twice as thin, right? So I hope that this analogy is helpful, guys. Um, let's now answer it. So I am going to write that if length is twice, cross-sectional area is going to be half. Um, will become half. Okay. Now our final point. So we now understand that the volume is unchanged and the cross-sectional area will become half. But how does that translate into resistance? Okay, so let me erase all this. So let's do some small algebra, okay? So our initial resistance, let's say in this part, is basically resistivity times length divided by cross-sectional area. Now, after we have done all of this, after we have increased the length by twice and the cross-sectional area have become half, we now want to find out the new resistance. So let's call that Rn, resistance new. The resistivity remains the same and the length has become twice, right? And the cross-sectional area has become half of the original cross-sectional area. So if you do the algebra, what I'm going to do is I'm going to separate this 2 and half. So 2 divided by half is 4, and all the other variables is on the side. This is basically the original resistance, right? So what I can do is I can just write 4 times R. So what we have found out, guys, is that the new resistance is going to be 4 times the original resistance. Okay. So that is what I'm going to write over here, that resistance will become 4 times. So suggestion is incorrect. Okay. So that is it for question number 17. I hope that you guys understand this. Please also make sure that you understand what they're saying in this question, that they're not actually adding another polymer, but rather stretching the polymer itself. And that is it for this video, guys. Don't forget to like and subscribe. I will see you in the next video.